Alright everybody, welcome back to the channel. Today our topic is 3D printers, just like the one behind me here. How they work and how to use them. Now this video is just going to cover the basics and I'll leave it to you to delve into any particular topic in more detail. I was introduced to 3D printers about 15 years ago at my first job, and subsequently I've owned several home versions of 3D printers for the past maybe 10 years or so, a couple different models. The one that you see in the background is called the Ender 5 Pro, and I would characterize it as a upper level entry model. Your first question is probably, how much do these things cost? Well, the Ender 5 Pro costs about $350 right now. It's actually kind of hard to find. It's a little bit older, so it cost me more than that when I first bought it. But you can buy a more entry-level version, a little bit more of a simpler version, for somewhere between $150 and $200 if you want to get in real cheap. But just like everything else, you can spend basically as much money as you want. For a intermediate level printer, you're looking $500 to $1,000, let's say. And then there's commercial type 3D printers like the first one that I worked with at my job, and that can cost $50,000 even up to $100,000. Let's first discuss how these printers work. There's a few different ways to do it, but they all pretty much work on a process called additive manufacturing. And in particular, this printer uses something called fuse deposition modeling. Now all that means is that the printer lays down a sheet of material, in this case plastic. And so it's a 2D sheet, and then another layer is built on top and fused together. Another is built on top of that and fused together. Another on top. And so in this way you have a 2D flat structure that builds up into 3 dimensions. I'll show you this thing in action in just a minute here. But what you'll see is the printer is heating up a nozzle. That nozzle is melting plastic into a paste-like consistency. And then it's just laying down very small layers in the fashion that I just mentioned. The resolution is the height of the layer, and that's sort of the level of detail you can get. That's a function of the printer itself, but you can also set the different layer height with some software, which I'm also going to show you. And so common layer heights are on the high end, on the best end, about 0.12 millimeters, very, very small, all the way up to say 0.32 millimeters, and that would be considered very coarse detail. So after you've decided on what printer you want, you've ordered it, it's arrived at the house, you've put it together because most of these are some assembly required, then you're going to want to figure out what material to use. And really there's a lot to choose from. They're pretty much all some version of plastic, and the most basic one is going to be called PLA. And if your printer comes with some filament, then it probably will be PLA. It stands for polylactic acid, but there's a lot of different materials to choose from. Let me show you what I'm talking about and give you some examples. This website is called Simplify 3D, and this is the materials guide page. And on it, you can see that there's many different materials. So each of these is a separate material or a type of material. So let's start off with PLA. That's the one I mentioned a second ago. So one reason why I like this website is because it kind of gives a rating in different categories here. So it has printability, how easy it is to print, how much of a pain in the butt it's going to be to tune your printer to use this material, strength, stiffness, and durability. And you see that PLA is very easy to print. That's why it's sort of the entry-level material. It's got pretty good stiffness and strength, pretty low on the durability. So if you have a material that you are going to use functionally as opposed to like a showpiece or a prototype piece, you might not choose PLA. But just to do a quick test of something, to do a quick prototype of something, to do something artistic, PLA is pretty good, and it looks very good as well. Also, it's very cheap. So that's the deal with these materials. Each material has different material properties because they're different sorts of plastic. And so that's why you might choose one over the other. Let me give you another example. PETG, and it has this long, complicated chemical name. PETG is another plastic that I like to use a lot. And so I use this one when I need something to actually function in the real world. And so if you look at the little rating here on the side, you see it's still pretty printable, although I would argue this. Yes, it is pretty printable, but I'd put it closer down here, more towards the middle. It's kind of a pain to print. But pretty strong, pretty stiff. Durability is why people use PETG. It's waterproof, or at least it can be waterproof. It can withstand higher temperatures. It can withstand UV light. So as an example, I had a cup holder that I printed, and I put it in my car, and I printed it out of PLA. And I noticed after a couple days, after a few hot days in the sun, it was starting to melt into form. And so I printed it in PETG instead, and it doesn't look quite as nice, but it's been in my car for a couple years now, and it hasn't deformed. The sunlight hasn't affected it. So that's a situation where you would use a different material that in this case could withstand UV rays and higher heat. And you can get kind of as exotic as you want. So this is carbon fiber filled, not as strong, very stiff, not so durable, a little more expensive. So you can just click on these and you can play with what materials you like and your intended use. Metal filled, right? So there's some metal powder in these filaments. Very stiff, not very strong, low end of durability, very expensive, right? So they're coming up with new materials all the time, and they all have different material properties based on your need. And I have a couple examples right here. So this one is the PETG that I just mentioned. You can kind of see how it looks. It's just this shiny plastic. And here is a version of PLA called PLA Plus, and it looks very similar. Look, you can, just kind of looking at them, you wouldn't be able to tell them apart aside from the different spools here, but they look very similar. However, they have the different material properties that I mentioned. And then of course you can get all sorts of colors that you want. Here's the PLA in a neon orange. You can get as many colors as you want. We're doing pretty good here. We've picked out our printer, we have our material picked out now, so now we just need something to print. And you can go two routes. You can either design something on your own, or you can just download a ready-made design. Let me show you what I'm talking about. So what's really cool about the state of 3D printing today is that there is a ton of designs just ready-made out there. This website is called thingiverse.com. There's many other sites like this, but it's a free website where people just upload their designs for free, and you can just browse what you want. So, you know, here's some, I guess this is Pokemon type stuff. Here looks like some sort of a Nerf gun or something. What's this? I don't even know. This is a dragon, a skull. It's Halloween time, so there's some spooky designs, and there's, I don't know, thousands, maybe millions of designs out there. Some of them very artistic, like this one. Pretty cool. Maybe you're into whatever this is. Cute dragon number one. But there's also a lot of more practical things. What's this one here? It's a toolbox. So really, this is really cool. And this reminds me of a feature like Star Trek, where there's a replicator. 3D printers are basically replicators. They're a little slower, but with a couple more steps than in the show or the movies, you could just download this file. You just click this button right here, you put it into your 3D printer, and it builds you whatever you want.
Just forget all that and give me a martini straight up with 2 olives for the vitamins.
And so before you go off and design something, you could just go to a website like this. You don't have to have any design skills at all, and you can just search for whatever you want. So if I want a bookend, maybe, okay, my books keep falling off my shelves, I can't stand it anymore. Here's like a very simple one. Okay, probably pretty much anybody could make this. But then there's super intricate and artistic ones like this one. if it comes up. Look, a thinker pose, right? Here's a karate pose, right? So people that are maybe much better at designing than you are, a lot of these people are better than I am. I could build something like this, but something like this, I'd be a little hard pressed to design. Now there is another way you could go too. You could design your own things and print them out using your 3D printer. What you're gonna need is something called a CAD program. CAD is computer aided design. And there's a lot of different programs out there. There's some free ones, there's some pay ones. The one that I like the most is called SolidWorks for my mechanical engineering days in school. SolidWorks is pretty cool. It's got a bit of a steep learning curve. So anybody can learn it, but it's gonna take a little bit of time. It's not super simple or plug and play like just downloading something from a website is. So just to give you an example, something that I'll do sometimes is I'll find a design that I want. This is a Thor hammer, Mjolnir, right? I'll take a picture like this, I don't even know where I got this, and then I'll design it in SolidWorks. So here's my design of that picture. So basically I would just look at that picture and design something. And I really like computer aided design because you can literally create anything you want. Any modern product is designed in CAD first. And so when I said that it can be complicated, these programs can be complicated, look at all these options you have in here. You can do more than design too. You can do engineering analyses and things like that. You can do stress analyses to figure out where something's going to break, thermal analyses to figure out what happens in deformation when you heat something up. You can really do pretty much anything that you want with these programs. They're so powerful, and I use them to design hammers from comic book characters.
Man, you are one pathetic loser.
All right, and so there's one more wrinkle to this process, which is that however you get your file, whether you design it in a CAD program or you just download it from the internet, the 3D printer only understands something called G code. It's just a code that tells the printer where to go, how much filament to lay down and things like that. And so you need yet one more program called a slicer. And what you're looking at right here on this screen is the program that I use called Cura. But again, there's many different ones, and this program is free. And so you see my little hammer here that I just showed you that I designed. And then what you have to do is you have all these settings here. There's, I don't know, 100 or more settings here. It seems to grow more complicated by the day. You have all these settings that tell the 3D printer exactly how to act. And so this part is honestly a little bit complicated, and it's sort of its own video. So I'm not gonna, again, go too deep into what all these should be. What you can do is you can find ready-made files online that have these settings all already figured out for you. And normally they're pretty good. They can probably get you a pretty good print. You can tinker with this stuff endlessly, and Lord knows I have. And I wanted to just say a couple words about upgrades. So these 3D printers are highly modifiable, and people spend all their time and a lot of money modifying and tricking out their 3D printer to make little improvements here and there, sometimes big improvements. I've done a little bit of modifying of my 3D printer. I'll say that it's definitely a intermediate to advanced move. I wouldn't recommend it until you're pretty comfortable with your printer and maybe have been printing for 3-6 months before you start thinking about upgrades. As far as the upgrades, the ones that I would personally recommend are something called an all-metal hot end, which helps to extrude the filament better. Something called a BL Touch or a bed leveler, and that just helps the printer level itself. It's one of the leveling the bed is one of the most difficult and rage-inducing actions that you'll have to do with 3D printing. You have to make sure that the bed is perfectly level because you're dealing with such small tolerances, and so the The print head has to be a very specific distance away from the bed, and if it's not, your print gets all screwed up. It's really annoying to deal with. So there's automatic bed leveling devices such as this BL Touch that I mentioned. So that's another one. And then a filament dryer, which I'll show you in a second here. A filament dryer is just something that heats the filament and it dries it out just like it sounds like, so that the material prints a little bit better. Now, if you're watching this video, obviously you're interested in 3D printers, but you might not know what are they even good for. So I can think of 3 good reasons to own a 3D printer. The first is as simple as it's just a hobby, meaning you don't need a reason. It's just it's a way to be creative. It's an outlet. It's a way to create things, to be artistic, and that's reason enough. So that's number one. The second reason is that you might want to rapid prototype something, right? And so this is a business type use. So if you do create something and you want to show it to someone, you want to sell something to someone else, then you might want to design something up and create a prototype of it just so you can put it in front of somebody, so you can fit check it in, whatever your end use is. So rapid prototyping was really the first use of 3D printing, and still probably the main use of 3D printing aside from hobby. Also, you can have a business that's 3D printing things for other people. So it's a business use, but your use is just to use your printer to print other people's ideas. The third and final use I can think of is just general home use. So we're all surrounded by plastic all the time, and pretty much everything. All the things I can touch, I can probably touch 15, 20 pieces of plastic just within my arm's reach right now. So we're surrounded by plastic all the time, but it does break. And a lot of it is sort of custom shapes and sizes. Well, with a 3D printer, you can fix pretty much any piece of plastic. You can replicate it. So that's kind of a cool use of 3D printers too. I myself have repaired broken pieces of things, or made little custom, brackets, or, something like that, where what I bought from the store didn't quite fit. So I went ahead and I made it. And that's a pretty cool use of a 3D printer as well. Finally, let's talk about some examples. Well, if you're a fan of my channel, and I hope you are, you'll remember that one of my more popular videos is the portable AC unit that I designed and built on my own. And so I used thermoelectric cooling, I wired everything up. Go watch the video if you're interested in that. But the enclosure I designed and I printed on this 3D printer right behind me. And that was part of the video. I showed that I printed it out of PETG because I knew I needed it to be waterproof, and I needed it to be kind of strong and tough and a functional part. So I printed it out of PETG as opposed to PLA. And actually, now that I think about it, in the video, I think I originally tried to print it out of PLA and it melted in the sun. So when I was talking about that earlier, that's from experience. So I grabbed a couple things that I personally designed and printed. So here's the Thor's hammer that you saw a second ago. Pretty cool. This is a hit with the kids. Here's the cup holder that I talked about. Very simple, right? So a lot of the things aren't flashy and crazy. They're just solving a problem. So the issue here is that the cup holders in my car were super small. They only fit things of about this size, but I'm a big boy. I like big drinks. So I wanted something that could hold my super big gulp, or whatever it is.
Hey guys! Whoa, big gulps, huh? All right. Well, see you later.
This part fits into my tiny little cup holder, and then this holds my gigantic beverage. What else do I got here? Batarang. This is fun. And you can see these are mostly PLA, some of them are PETG, but different colors. What else? Chess piece. You could print a whole chessboard if you want. An apple, right? So this was actually for a Halloween costume. So cool little apple. Designed this, and this is something that looks simple, but all of these curves and lines and bends and everything, they all have to be designed. It's maybe not as simple as it looks. Washington Monument from my hometown. Kind of cool, right? So some of these are artistic, some of these are more functional. This is a card holder. So you can hold your favorite LeBron James card or whatever you want here. This card holder actually has kind of a cool story, so shout out to my good buddy and fellow YouTuber Cardboard Viv. So Cardboard Viv reached out to me, and he's got a channel that I'll link to it in the description. It's a very fun channel, go watch it. But he asked me to design him a card holder to better hold his graded fancy cards. And so I said, okay, no problem. I looked at a few off-the-shelf examples and I thought I can do better. So I went ahead and I designed something through SolidWorks and I printed it, and this was the first iteration. And then here is sort of a final iteration, and there's some small but noticeable differences between the two. So this one here, the later one in black, this one's a little bit taller, the angle's a little bit different. It's got a nice CBV logo here, whereas this one didn't. Let me go ahead and show you how this one's printed. So I'm going to use this awesome card holder as an example of how the whole process works front to back. So here I have the model in SolidWorks. I created this thing from scratch. Here's how it looks. It's got all the correct units and everything. It's the right size. So I have this 3D model. Okay, then I have to put the model into my slicer Cura. I've got it right here. And you can, once it's in this program here, you can do things, you can flip it around, you can move it. So here I'm saying, okay, make the bottom align to the build plate here. I can rotate it around to print in a certain way. You can see the size of it and see how much space it's going to take up. Okay, let's just rotate it like that. You can even create multiples. So I can do multiply selected. And I can make, let's say, 3 copies. And there they are. They're kind of jumbled together. But this would print fine. Then let's take these off for a second so you can see it better. Okay, I've got my profile right here. I've got all my parameters dialed in. Then I click slice. And it's going to tell me down here how long it's going to take, 3 hours and 51 minutes. So that also kind of gives you an idea of how long the printing takes. And this tells me how much material I'm going to use. If I click here and preview, this is pretty cool. I showed you this with the Thor's hammer, but you can see how the printer is going to build it up. So here it is. Now what I did is I printed this on my 3D printer and I made a time-lapse video. So here I'm just setting it up. Okay. This little thing right here that's glowing, that's my BL Touch Auto Bed Leveler. And that's going to make sure that the bed is straight and level and the print prints correctly. So it's doing self checks right here. Again, I've got this sped up. It's a time lapse. So that's why I think this is pretty cool. So right now, now it's about to start the print. So it's building an outline. And this looks exactly like my slicer said that it would look a second ago, right? So you can see it's just building it in. Here's the bottom. And let me just kind of scroll through this. Look at how it's building up piece by piece. Really cool, right? This is some futuristic stuff. I can't believe we have this technology. I mean, literally anything you can dream up, you can print. It's an incredible machine. And it's just building it slowly, layer by layer, over those 4 hours that I've sped up here. And there we have it, the end result. So at the end, here we have our final product. I think it looks pretty good. You know, I think, not to belabor this point too much, but what's so cool to me about 3D printing is that you start off with just an idea in your head. It doesn't exist. You design it on a computer, still doesn't exist. But we have these printers that can make your thoughts a reality, right? I dream this up and now it's a thing I can hold in my hand. And I can show off my sweet Bas Rutten UFC legend card right here. And it's gonna look real good. So Cardboard Viv, actually sells these on his eBay page. I'll link to that in the description if you're interested, but I think this was a pretty cool project. In conclusion, 3D printing is a really fun and interesting hobby. And I know that I've sort of presented a lot of ideas here. I've talked about the software and how it can be complicated, but please don't be intimidated. I really feel that anybody with just basic computer skills, if you figured out how to get to this video, you can print something successfully on a 3D printer. Start off with just ready-made designs from Thingiverse or some other website out there, download it for free, and just print things out. You'll catch the bug, and pretty soon you'll be designing your own 3D models. And with that being said, I think we'll end this video. And printing this sweet cardboard Viv trading card holder is our achievement for the day. So thanks for watching as always. If you like my content, like the videos, subscribe to the channel, and I'll catch you next time.